We are going live again. Oh, I gotta get my ladder. 1, 2, 3. We'll do that for now. So, we are talking about abacus, and let's put it into the books. So do you know how to get to my sister's house? Yes. Send me the address. Send me address. Even better. All right. So what we're going to do is we're going to talk about the abacus and how to count on the abacus. Abacus. Okay. So if we are ready, we are going to start. What are we going to do? We're going to start counting. Now, what we need to do is we need to understand how to read the abacus because that's how we all start. Now, to start the abacus, ooh, that's not good. Come on, buddy. Come on, buddy. Come on, buddy. Let's get it with it. Okay, good. So here's my abacus, and what I'm going to do 1, 2, 3, 4. So if you notice, oh yeah, so if you notice, I have 1. So if I have 1, oh, maybe I shouldn't do that. Maybe I should do this. So if I have 1, oh, I don't want to do that. Okay, good morning, good morning, good morning. Hello, everybody. Welcome, welcome, welcome. What we're going to do is we're going to talk about the abacus. It is a counting tool. We're going to talk about math. I don't know if it's too early to talk about math or if it's too late to talk about math, but I'm going to talk about math. The first thing we're going to do is we're going to understand how to read the abacus. What is this thing? This is the abacus. This helps me. This helps me count. I was just thinking, like, one of the things I was thinking, I was like, easy to use. An abacus is easy to use. Like I'm trying to sell it. Like everybody's trying to sell on TikTok. I cracked myself up. Okay, what are we doing? 1, 2, 3, 4. Easy, right? Easy to use. Just like it's just like one of those things. So when we do 4, right? We have 4. How do I know this is 4? Well, we do know 4 because there is a horizontal bar. The horizontal bar is what counts the abacus. So we know that when the 4 beads touch the horizontal bar, that is what we count as the abacus. That's what we count the beads. So we have 1, 2, 3, 4. Notice that we don't have any more beads at the bottom, right? So if we don't have any more beads at the bottom, where do we get 5? Well, the cool thing about it, the interesting thing about it is that 5 will always be in the top bead. The top bead will always be 5 no matter what. So the value of 5 is this, 5, 5, 5, 5. These are all 5s. So when we do 5 and then the bottom bead is 1, the bottom bead has a value of 1. Because the bottom bead has a value of 1, we know that this would be 6. Now we get to the point where the kids can start decomposing. So we have the number 6, and so this is 6. As we decompose, we'll see that this is 7. How do we know that this is 7? Well, we count 5, 6, 7. Good morning, good morning. Thank you everybody for joining me right around the corner. Yes, thank you so much. Yes, thank you so much. I'll see you soon. 7. This is 7. This is 5, 6, 7. Welcome, 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 everybody. What are we talking about? We're talking about this crazy thing called the abacus. The abacus is easy to use, and you can buy it on my TikTok shop. No, I'm kidding. I'm kidding. We're talking about the abacus, and the abacus is a counting tool. We can do adding, subtraction, multiplication, division. Easy to use. I'm going to keep saying that. I cracked myself up. Okay. What are we doing? We're going to count. The top bead will always have a value of 5. The bottom beads always have a value of 1. So when we combine them together, this is 7. So we have 7, we have 8. How do I know? Because when the beads are touching the beam, this is what the beam is. Because it's difficult to say beads and beam. Okay, so this is the horizontal bar. This horizontal bar is the beam. When the beads are touching the beam, when the beads are touching the horizontal bar, they are now counted. Because they're counted, we know that these are going to be 0. Thank you so much for the likes. These are 0, and then this is what's counted. So right now, this is not 7. This is 8. How do I know? We have 5, 6, 7, 8. Welcome, everybody. Welcome, everybody. Thank you for joining me. Let me know if you have any questions. But what we're doing is we're going to count on the abacus because everybody who wants to start to understand how to use the abacus will need to learn how to count on the abacus. And it's just one of those things that this is where we start. Because this is where we start, I'm just showing how we understand how to read it. So what's going to happen is when I want to do 9, right? I'm going to do 9 and it looks like this. This is how the 9 looks like, right? So we have 5, 6, 7, 8, 9. Now the question is why do I do How do you do 2 times 5? 2 times 5, you have to memorize the multiplication fact. That's just hands down. But when we start doing double digits, that's when we start doing it on the abacus. You could do is cumulative addition, which would be like 2 plus 2 plus 2, right? And then plus 2 again. You could do that, right? Or you could do 2 times 5, which is 5 times 5. You could do that. But, I mean, that would be the only way to do it on the abacus is to do cumulative addition, if that makes sense. When we start doing multiplication on the abacus, we do like more digits, like 12 times 6, or we do 48 times 32. You know what I mean? So in the abacus, we can actually do higher than the multiple math facts, if that makes sense. So the next question would be like, yeah. So, hey Maura, I had a question. Your teacher, is that from a public school? Or is the teacher a private tutor teacher? I was just curious. It's just a curious. I was just curious. So going back, and did my tip help your daughter? That would be really interesting to know. So going back to here, how do I know that this is 10? Well, if you notice, we have the dot that's over here. This dot tells me that we're going to start the ones at this dot, right? So why are we going to start here? Because that's where my dot is. It just helps to label. There's also this dot here. You could use this dot over here. It doesn't matter. It just depends on how big or small your number is. So I'm going to use it here because it's easier to show that we're going to add more numbers. And then here we have these ones. This right here would be the decimals. Just like, okay, so again, just like how we write 10, we have our ones and we have our tens. So when I put it on the abacus, that's our ones and our tens, if that makes sense. I'm going to make this better. So, yeah. So when we do it, we have our ones and our tens. So when we count, we do 11, 12, 13, 14, and then we have 15. We have 16, easy, right? 17, no, not 17. Why not 17? Because we have a 2 here and we have a 6. We have a 2 here and a 6. Please sure. Oh, okay. So we have a 2 here and a 6. So what does that mean? That's 26. And then we have 27. And then we'll have 28. How do I know? Because as the beads are touching the horizontal bar, as the beads are touching the beam, right, the horizontal bar, we know that this is counted and then this is counted. So now we know that this is 28. And then the top bead will always have a value of 5. Because it's a value of 5, that's how we count. 5, 6, 7, 8. We will know and we will start subitizing that this is 8. So when we do this, we know that this is 9. We will start to recognize, as we work with abacus, we will start to recognize what the numbers are. So we have 29, right? And then 30 is 3 and 0. Does that make sense? So what are we trying to do here? So let's start counting. Let's start recognizing what we're trying to do. So everybody, please put in the chat, what number do you think this is? Let me move my book. Maybe I should do that instead. So in here, if I have my ones, my tens, and my hundreds, put it in the chat what number you think this is. Put it in the chat what number you think this is. Yes, Captain Peach. Exactly. Danny, you're missing the top bead, which is a 5. 6. Yes, even. So why do we talk about it? Well, we have to remember that the top bead, when the top bead touches the beam, we have to count the 5. So we're going to count 5, 6. So this is 6. And then we have 1 and we have 3. So we have 613. Easy, right? Easy to use. Oh, yeah. Michaela, now the reason why we don't do 0, 0 is because this is now going to be the decimals. So when I write, if I find my book, when I write, if you notice, this will be where my decimal is. Just like as we write it, we have 613.00. Now, what does that mean? Just like when we have our money, we cannot, it doesn't take a place value. So what's going to happen is we have our ones, and then we have our tens, tenths, and then hundredths. So if I'm going to change it, I can change it to 25. So now we have 613 and 25 cents. Make sense? So now we have what 613.25. Jenny, I'm not sure how you got 10. So when we talk about it, we have our ones, our tens, our hundreds. Yes, great. Yes, because, I mean, in the end, here's the thing. If I choose to use this as my, ones, now we're talking about the decimals over here. So if I choose this to be my ones, then what will it look like? So anything after the dot is on the horizontal line becomes a decimal. The horizontal line is to show that the beads are counted. The dot on the horizontal line indicates the label of my place value, if that makes sense. So here, I'm going to use this dot as my ones place. But let's change it. What number would it be if I use this as my ones place? So it does depend on what you label, and it's all about perspective. Right? Because I could be this as my ones place, or this is the ones place. Now one question is if this is my ones, what is my number now? I'm going to slowly put it down because it's very delicate. So anything after the dot, simply angel. No, there's no one. So Captain Peach, when we talk about it, this is no longer the ones. We're going to tell you this is the ones. So if this is the ones, this will be 1. So there's a 0 here. And then we do dot, right, between these two columns. And then this will be 6, 1, 3, 2, 5. Does that make sense? Yes. Thank you, Lisa. Exactly. Because now what we're doing is we're switching the location, right, of the ones place. So we could either use this one or this one. It actually doesn't matter. It just depends on how big or small your number is. So that was the reason why. Now, this one is a 7-column abacus. I labeled it because I got tired of counting it. This is a 13 column. So with the 13 columns, notice that there's more dots. So now the reason why there's more dots is, again, you can choose any dots, but now it's helping us also label our group separation. So just as we do, let's say 6,000 without a comma, right? 1, 3, 2, comma, 5, 4, 7. Okay, so what does that mean? Well, we do 1 million, right? So when we do 1 million, let's see if I can do 1 million on this. I'm going to start in the middle. So we do 1 million. We do 6, we do 1, we do 3, we do 2. Notice the 2 is in the thousands. This is the 2. This is the thousands. Let me move my. Let me see if I can line it up with our numbers. So we have 6,132,547. 7. Does that make sense? Are we okay with that? So I started in the middle. This is my now ones, and now I have multiple dots. The multiple dots helps me label the group separation, just as we have commas. The commas don't take a placement. The commas don't take the place of a place value, just like the dots is not meant for a place value. The dots are meant to be. It is the dots is not a decimal. The dots is a place value. Yeah, that's a little bit of a tongue twister, but it's still easy to use. So the first thing we're going to do is we're going to try to understand how to read it. Once you learn how to read it, it is really easy to use. And there's just what it is there's a bunch of formulas that we actually really need to know and how to do things. But first things first is understanding how to do some adding and subtracting before we can go into multiplication. So are we okay? Anybody have any questions? Anybody have any questions? Let me know. I'm going to continue on with understanding how to read the abacus, and I'm going to use my colorful one. Cool. So welcome everybody, welcome. My name is Lynette and I'm an abacus teacher. I have abacus classes and I also have abacus books. I'm all about abacus and I'm trying to abacify everything. I'm trying to make abacus modern because abacus is a really, really old tool, which is interesting because they're using a lot of manipulatives. What do I mean? Well, funny, we have a die. They use this in preschool, and that's a manipulative. And then we have these blocks. These are also manipulatives. But they don't talk about the abacus because they think it's hard, but it's not. It's easy to use. Okay. I don't know if you can hear my dog, but my dog is just like, I want to play. Anyways. So this is my book, and the book is about how to, so interesting, thank you for teaching. Oh yeah, not a problem. I'm happy you're able to understand and enjoy, because it really is easy to use. But what we're doing right now is I'm just showing the book because I wanted to show that what we do in the beginning of everybody has to start like learning how to read the abacus. So it's not like, I'm an old person and I know what an abacus looks like, right? No, it's everybody, and everybody who starts the journey on abacus will need to learn how to read the abacus. I actually didn't learn the abacus when I was a child. I learned the abacus when I was old. It was because my dad went to a business trip and some parent went up to him and said, you got to teach abacus to your children because it's the greatest thing next to sliced bread. And he's like, you know what? I want my grandkids to learn abacus. And he comes to me and my brother because as Chinese parents are, they're like, you're going to learn it and you're going to teach your kids. And I'm like, I don't even know what an abacus is, really. When I was growing up, I think I was like 20, I think I was like maybe 30. 20, yeah, I was probably 30 when I learned abacus, and I'm like, wow, my God. But now, as I go through abacus and learning it and all, and I'm like, oh my God, abacus is the greatest thing next to sliced bread. That's how old I am, just so you know. So when we start counting it, right? I've been teaching abacus for more than 20 years. So in the book, what I did is I wanted to make sure that the children would be able to understand that, you know, these are the numbers and how it relates to the abacus. And so what I wanted to do is I wanted to show, okay, if this is 2, how do I show 2 on the abacus? And then this is 2 on the abacus. And this is where I have the number and then the picture and then the physicalness, right? You can do the same thing with these, right? If I want to show 2, you would show 2 blocks. Now, the difference between these two, the difference between the manipulatives, well, they can see the quantity. If I do 5 on the abacus, that's the one thing, right? You don't see the 5. We have to imagine that the top bead will always be 5 no matter what, right? So we're going to continue on, and then in this one we have the lesson 2, which we start talking about numbers from 5 to 9. So what does that mean? We have 5. The idea we did, the reason why I kept to 9 because I didn't want to talk about place value with the preschoolers, because the terminology of place values, it kind of is too much for them, right? So what I did is this book is only from 0 to 9, and what I noticed in school is we don't teach the kids to start from 0, but abacus we actually have to start from 0 because we start with a clean abacus and then we start adding and subtracting. So here when we count 1, 2, 3, 4, you can't start from 1, right? It doesn't make sense. So on the abacus we have to make sure that it is clean. It is 0. Okay, so and then it goes further on, like there's more activities to reinforce what the kids are learning. So if I wanted them to color the 2, I wanted them to see that there's a number 2, and then I wanted them to show me on the abacus that this is 2. So it's a lot of one-to-one, and it's a lot of just understanding and doing bead recognition. So we're going to keep going forward. This one was, we do counting forwards, we're counting backwards, and then we count what's in between, and which one's smaller than, and what one's bigger. So the reason why I started doing this is because I wanted the kids to understand the relationship of numbers. That's not a problem. So then afterwards, we actually start going into adding and subtracting. So let's start adding and subtracting. But notice that when I do it, I say +1. Now, why do we want to plus the 1? Well, what we're doing is we're only focusing, in abacus, we focus on the procedure, not the result. So what does that mean? Well, when we look at preschool math, when we look at elementary school math, it's really quite interesting. They focus really on the result. So one of the questions that they had, and I was doing research, and I found this YouTube video, and they're like, okay, let's do 3 plus 5. And what's the answer? That's 8. Whoa! And they were being exciting and, you know, trying to show that there's a relationship of, you know, that's the answer. On the abacus, let's take a look. On the abacus, it is 3. Whoa, that didn't work. So we have 3, and then we add the 5. So notice that do I have enough beads? So the question would be in abacus, do I have enough beads? Yes. So I can add my 3 and 5, and that will be 8. Okay, fantastic. Not a problem. So then the next question is 7 plus 1. 7 plus 1 is 8. Not a problem, right? Because how do we look at it on the abacus? On the abacus, we have 7 plus the 1. Do we have enough beads to add the 1? Yes. So I'm going to add the 1, and my answer is 8. Okay, great. Now notice what they did in the video is that they really focused in on the result. And they're like, yeah, it's 8. This is fantastic. We know 3 plus 5 is 8, and 7 plus 1 is 8. And 8 is the greatest number next to sliced bread. Okay. Then the next question was 4 plus 4. Now this is where it gets a little hairy. Abacus, actually, we don't memorize our doubles. We don't memorize our doubles. Why? Because it doesn't make sense. On the abacus, when you were, I don't know how everybody was I don't know how old everybody is, but when I was a kid, I had to memorize our doubles. And then there were strategies like, doubles plus 1 or doubles minus 1. I was like, yeah, okay, well, whatever. So we know that this is 8. And then again, the video was like, yeah, this is 8. So if we know 3 plus 5 is 8, and 7 plus 1 is 8, and 4 plus 4 is 8, that's great. But in abacus, we actually focus in the second addend. Now, what does that mean? Well, let's take a look. We have our 4. That's not 4. This is 4, right? We have our 4. Now, we're going to add another 4. Do we have enough beads to add a 4? No, we don't have enough beads to add a 4. So what do? Okay, so this is the next step, right? The first thing we did is we did the simple, which means we don't have any beads. Do we have enough beads to do? Yes, that's what this is. Now the next one is right here. The next step is to understand that we actually have to start using formulas. The interesting thing is in school, we're teaching children now that we're going to learn how to make a 5. So 4 plus 1 is equal to 5. Or 1 plus 4 is equal to 5. So now we're going into the next step. We're going to the next phase. But in school, this is as far as it goes. That's all they do. This is how you do a 5. This is how you make a 5. Learn to make a 5. Okay, great. That's fantastic. I love it. But abacus takes it one step further. And this is how easy to use abacus. So what are we going to do? Abacus is the gateway to complex math. Abacus is the gateway to algebra. We do a lot of algebra. Don't be scared. We do a lot of algebra, but it's part of the system. It's part of the methodology. What does that mean? Well, we're going to isolate the variable. When we isolate the 4, we're going to look for the 4. What we're going to do is we're going to move the 1s over here. We're going to eliminate the 1 from this side, and we're going to add it to this side. So I'm going to rewrite this question, this equation, this addition sentence. I think that's what they call it. I'm still trying to figure out the terminologies. But in abacus, what we do is we say plus 4 is equal to plus 5 minus 1. This is a hands down formula that everybody needs to memorize no matter what. You could call it small friends, or plus 5. It doesn't matter. It's all the same. Everybody, if anybody who knows abacus will know that this is a hands down concept. Just like learning number sentence. Oh, that's a good one. Number sentence. I'll have to remember that. Okay. So what are we doing here? What we did is we isolate the variable. Now what we're going to do is we're going to substitute this equation, this number sentence, into here. When we substitute it, again, that's another mathematical terminology that we don't say in abacus. All right. So what does that mean? What do we do? Why do we call the operators? Why do we say plus 4 plus 5? The reason why is because to gently remind us that when we add the 4, when we add this 4, we're going to add the 5 and then take away the 1. That's why we do the plus 5 is equal to plus 4 is equal to plus 5 minus 1. And if the kids are young, have them say it out loud. So we say plus 4 is equal to plus 5 minus 1. I've been saying it for a long time. So I'm getting all the kids to do it. So when we do it, right, we add the 5 and take away the 1. Plus the 5 minus the 1. And that is our answer. But notice we have to take it one step further. We have to know this formula. This is an abacus formula. Everybody knows it as a formula. This is what we do. So then there's the other ones. So let's take it one step further. Let's take it one step further. let me find my question. I'm going to put it over here. So let's take it one step further. Here is some sample questions. Now, if you notice, again, what I'm doing here is I'm focusing on kids below the age of 7 don't have an internal voice, so they have to speak out loud. Oh, that is really good to know. That's really good to know. Because the kids, so when I talk to children and I teach my students, and if they're younger, that makes sense, because what I do is I have them say it out loud, because as you say, even I say it out loud, and when I say it out loud, it makes me focused on what we're trying to do. So going back to here, notice that we have 4 plus 4. Again, we don't learn our doubles. Now let's take it one step further. Let's take it to 2 plus 4. Again, I'm going to add the 2, and then I'm going to add the 4. Well, notice I don't have enough beads of 4. Hello, do you sell this abacus? I do sell this abacus. You can see it on my website. I do sell it. It is my website. If you go to my bio, you can go to my website. But that's my website. It's learningwithlynette.com. Yeah. But yeah, there's a link in my bio for a free activity. I think that in my bio is a free calendar. You get a free calendar with all the abacus. So what does that look like? Before I continue, let me show you what you'll be getting if you sign up. But you can see the abacus. So it's I have to do March, but there's the abacus, and so what I did is I have prompt questions, and with the prompt questions, it looks like this. So you have the calendar, and I have it where each number is on the, as the date goes. It's a calendar with an abacus. And so you get the quarter view, and then you get the month view. Now, with the month view, you can color it in, so it's easy for the kids to start coloring it in. And then I did 2 versions. One is a simplified abacus, and then the other version is a regular abacus. Why? Because sometimes it's difficult for the kids to see what the number is. Notice it's a little bit more simple. There's no extra stuff. So what I did was I gave 2 sets. So if you get it now, you'll get it February, but I'm going to send out March pretty soon, because I just got to get March ready. But yeah, those are the 2 different ones. That is the 2 different, and that's it. So yeah, if you sign up, that's what I have. So if you want that, it's available. It's in my bio. Okay, so going back to here, we're going to add the 2. Why are we going to add the 2? Because I wanted to show that how the 4 is the 4 is versatile. Understanding the formula of the 4 is versatile. What does that mean? So when I add the 2, there's not enough to 2. There's not enough beads to add the 4. So we know when we add the 4, it's plus the 5 minus the 1. So we plus the 5 minus 1, and we have the answer is 6. So the biggest thing is to understand is that the kids will need, everybody, not kids, but everybody needs to understand that plus the 4 is equal to plus the 5 minus 1. And then it goes into further, right? We actually, what's another way to make a 5? To make another 5, we do plus 3 and then plus 2 is equal to plus 5. Now the reason why I wrote it with a lot of pluses, because we also do the minus as well, right? So in the minus, so let me finish this sentence. Let me finish this number sentence. Thank you so much for that. So let me finish this. So what we do is if I wanted to isolate the 2, it will be plus 3 is equal to plus 5 minus 2. Because what do we do is we take this 2 and we move it to this side. So we rewrite it, and now this is another formula that everybody needs to memorize. So these are formulas that we need to memorize, and these formulas all have to do with adding the 5. So when we add the 5, it's easy to use. Yeah. Anybody have any questions? Anybody have any questions? So we're going to continue on. Yeah. Anybody have any questions? No. Follow the live creator. Hi, no. The number jumps the fence. Oh, hey, that's a good one. Blue bubbles. That's a good one. Number jumps the fence and the equal sign. And the equal sign's the fence. Yes. But we actually don't, I don't show this to the kids. The kids just know this. So what I was trying to do. So the reason why I have it this way. Again, so the kids, it's difficult for the kids to understand that we have the 5. So what I did was I said, okay, there's 5 cats. Yeah, but I don't but I don't show them that they jumps the fence. That's why I don't say that. But it makes sense. But here, okay, so with the little ones, like yeah, so for the little ones, they didn't understand what the 5 was, right? So I had it into a story, just like your story here with the number jumps the fence. Just like here, let's do 3. Now, I have 5 cats in a tree. I'll always have 5 cats in a tree, and I, use my hands. So if there's 5 cats in the tree, I grab 4 cats, right? Because I want to add 4. I grab 4 cats, but 1 cat runs away. So I grab 4 cats, and so that goes to the tree, and I take away 1. So that's what I was doing for that's why we have cats in the tree. But yeah, and they were able to understand that, oh, I go to the tree with 5 cats, and I grab 4 cats, and 1 cat runs away. So, and it's the same thing with the 3. So I grab 3 cats, and 2 cats run away. So if I had 4 plus 3, I got to go to the cats in the tree. The cats love trees, apparently, and there happens to be 5 cats. So 5 cats, so if I grab 3 cats, 2 cats run away. So 2 cats run away like that. Yeah. So and just like the number jumps the fence, it's the same thing with, like, I was trying to make it into a story. So I have 4 cats in a tree, and then more cats in trees. So, but there are always going to be 5 cats in a tree. And then with the 5 cats in the tree, it just kind of makes sense. And I noticed that was what resonated well with my students. And so in here, all we're doing here is we're solidifying and reinforcing the concept of making a 5. So we have activities where they can go through. And what are we doing here? Well, we answer the question. We start from here. We answer the question. We have 8. And then we take away 6, because by then they'll know how to minus the 6. This is a great story for teaching. Yes, thank you. Thank you. I appreciate it. It was one of those things, like, it was kind of difficult to, like, get to, because when I was learning abacus, we were just said memorize. Whereas now I'm like, okay, how do I make it more modern? And being modern, it's about, try to bring in stories and try to be more interactive. And so if you look, the other abacus books that are out there, this is what it looks like. And this is what I learned from. When I was learning abacus, this is what I learned from. And doing this was kind of monotonous, and it kind of put me to sleep. So, and this is 60 questions. This is like no joke, right? And this is what they do. And it doesn't matter if it's in Chinese or whatever. Even in English, it's really boring. I am a halta. Try to make. I don't know what a HLTA is. So I try to make all learning interactive. I'm not sure what HLTA is. I would be interested in that. So going back to here, I made color by number. So the idea was that they would have to figure it out. Oh, I'm still right here. I'm sorry. I'm right here. So there's the start here. So we have the 6. I'm sorry. We add the 8. We take away the 6. And then we add the 3. Notice there's not enough beads to add the 3. So that's where they had to really memorize their formula. Higher learning teaching assistant. Oh, interesting. Yeah, that's very interesting. And then one of the things was trying to get this into, like, was it not interactive. The word escapes me. I'm sorry, I'm back to here. So plus 3. So if I want to add the 3, there's not enough beads. So this is where the story is. I go to the cats in the tree, right? I go to the cats in the tree. I'm going to touch the 5. I'm going to add it, right? I'm going to go to the cats in the tree. I'm going to take 3 cats, and 2 cats run away. Not international. It was intervention. Intervention. There was another person that was in math intervention, and she found that the abacus was really interesting. And I think it's the greatest thing. And I think it would be very beneficial to incorporate this. Because why? Because we already incorporate other manipulatives like this. So if we incorporate other manipulatives, we should, in my eyes, we should introduce abacus, because it makes a lot of sense and it's easy to use. I'm trying. I found this one TikTok. They were talking about an amplifier for, like, doing live stuff. And it was just funny. He was like, it's easy to use, easy to plug in, easy to use. And I'm like, oh yeah, abacus is easy to use. Yeah, intervention for the SEN kids. And kids, they need physical things to help learn. You know what? I wouldn't even differentiate, like, yeah, I wouldn't even differentiate. I think all kids, I think even adults, we all need something to tangible to have in our hands to see what we're doing. Because when I start doing multiplication on the abacus, you'll see how it's easier to note. Because what it is I think in school we push the kids to learn the symbols, and the symbols are abstract, and I think we push it too quickly. So now with the Common Core, they're starting to use manipulatives. They're starting to use representation for numbers. So like when we start doing like multiplication, they're like, okay, make your box and then put it into like this, and then this is what 2 times 3, and they're trying to make it more. They're trying to make it more visual, and it's the same thing. So even when they go into like higher math, um, abacus actually follows my students all the way to till whenever. I mean, you can use abacus all the way to multiplication and division if you choose to. If you choose to continue to use the abacus instead of a calculator, right? You can do all of that stuff. I mean, obviously you can't do trig or anything, but abacus is the gateway to more complex math. Abacus is a gateway to complex math. Why? Because there's a process and a framework when we start going through things. So you notice I started with the process. I like how each bead has its own color and identity. Which number is it? Yes, I like it too because it's specific for the young children. Why? Because there's one where the abacus is like a single color here and a single color per column. I didn't like that one so much. I like it where it's this one, the beads are on the top, which is blue beads. And then these ones, all the lower beads have a value of 1. But be careful though. Don't say that the green bead is only the one bead. When we talk about it, we want to say the one bead. So you want to move. If I have two and I want to add the 1, the idea is to show that we're moving the one bead. So you have to be careful not to label the green bead as 1. So when we take away, right, where the red bead is not 1. What we want to do is we want to say minus the 1 is the one bead, not the red bead. So you have to be careful when you have your vocabulary. So here, let's say we have 3 and I want to take away 1. I want to take away 1. Notice when I take away the 1, they will see that we're going to remove the 1 from the thing. So it's easy for them to see we're going to subtract. So but notice it's the orange bead now. So you have to be careful with the vocabulary. So I would just say take the 1 bead away, not take the orange bead away. But I do like it because it is colorful. But if the colors are too overwhelming, there are these ones where it's the single color and it's just as good. So it does depend if it's if the color ones are too overwhelming. Yeah, take away 1 bead, not just red bead. Exactly. Hey, Bapple, how are you doing? So yeah, so be careful. I'm very specific when I talk on the abacus, just because I don't want to have the confusion of saying, oh, move the green bead, that's 1. I'm very specific. I say no, just move the 1 bead. So when you take away 1, or you take away 2, right? So the idea is you could take away this 2, you could take away this 2, you could take away this 2. So it depends on like how you do things. But again, if the colors are too overwhelming, like overstimulating, you can use it's good to use the single one. And the single one, if you choose to get one, if you want to do multiplication and division, I would recommend doing the 13 columns. There is a 13 column colorful one, but I think after a while it gets kind of tired. I get tired with all the colors, so then I'll just use this one. And it works exactly the same. It's just the different colors, right? So we have our top bead, right? 5 and 5, 6, 6, 7, 7, 8, 8, 9, 9. And then the other thing was for the bigger abacus, I would start in the middle because then you have your decimals and then you have your bigger numbers, your whole numbers. Yeah. Yeah. It's like showing how you can make 4 with your fingers in lots of different ways. It is very much so. And then that's why we have I was showing the die, because the die is also a manipulative as well. So going back to here, that's why so when I was creating this book, I only specifically focused on making a 5. Making a 5 is one of the fundamental formulas that the kids will need to learn. To memorize, to see the number pattern. So let me show you like what I was talking about. 4, you'll notice that if I'm trying to add the 4, I'm going to take the one bead on top and one bead on bottom, and I'm going to move them together at the same time. But that will always be the case, right? So it's interesting. What's really interesting is you will see that this is the pattern. We talk about number patterns in math, which is really interesting, right? We say, okay, we could do skip counting. If I do like skip counting, 1, 2, 3, 4, right? We do 2, 4, 6, 8. Okay, great. We do 2, 4, 6, 8. That's great. But now if we can do it on the abacus, what does it look like? It starts younger. It starts earlier to see the number pattern, because when we start doing adding and subtracting, we don't do skip counting. We don't do skip counting in abacus. What we do is we do adding, and we utilize the formulas. So when we look at it, we want to add let's say we had 2, we want to add the 4. Notice I add the 4. I move the top bead and the bottom bead. Most of the time this will be 4 if there's not enough beads, right? The other way is if I did 3 plus 4, right? I'm still using these 2 beads. So this is the number pattern that we're talking about. Now it's the same thing with 3. So if I do 3, I do 1 bead on top and 2 beads on the bottom. So this is the number pattern of 3. And again, I want to show, where is my formula sheet? I don't know where I put it. I keep misplacing it. Oh, here it is. So I don't know if this is what they're showing in school. Making a 5, you always move 2 beads. Yes, you could say that. The reason why I hesitate is because now we're going to make a 10. It's a little bit more than just, it's a little bit more. So why do I say that? Well, let's make a 10. Can you cover the basics? Oh, hey, the real Kelly Brook. Yes. So let's do that, and then we can talk about making a 10. Okay. So what we can do is we're going to count on the abacus. The reason why we're going to count on the abacus is we're going to use this bead right here, this dot. This dot tells me that this is the ones place. So when we count, we're going to do 1, 2, 3, 4. Anytime that the beads are touching this horizontal bar, anytime this bead, hey, Ethan, isn't it late for you? We have 4. Touching this beam, this horizontal bar, that's how we know that this is counted. Because we know this is counted, notice that there's no 5. Well, the top bead will always be 5. So then we have 6. How do I know? Because we have 5, 6. And then on abacus, we start introducing how to count on. Counting on is a process of starting from 1. But here in abacus, we don't start from 1, we start from 5. So we have 5, 6, and then 7. 5, 6, 7, and then 8. 5, 6, 7, 8, 9. This will always be 9. This is 9. This is 9. This is 9. This is 9. So what's the difference? Well, now if I say this is 9, that's great. But then this is not 9. This is 90. Now we start talking about place value. So we have our ones, we have our tens, we have our hundreds, we have our thousands, and then we have our 10,000s. On this abacus, I don't have very many columns. So we have to be careful with I have to be careful with the questions that I'm using. Okay, so that's the basics of understanding how to read the abacus. When you read the abacus, which is easy to use, we're going to go into making a 10. So the reason why I was hesitating with making a 10, reason why I'm saying with the 5, when we make a 5, we're moving 2 beads. That is absolutely true. That's absolutely true. That makes sense. Because when we add the 5, that's what we're doing, we're making a 5. But now the next thing is when we make a 10. I wouldn't say that when we make a 5, you're only using 2 beads. I wouldn't use that as a rule. Because when you start getting to the bigger numbers, like these numbers are really small. When we get into the bigger numbers, you have to kind of keep track of where your numbers are. So let's do 4 plus 4. So now what we're going to do is let's do cumulative addition, right? Let's do 4 plus 4. We know in our previous one that if I add 4, I don't have any more beads. So what am I going to do? I'm going to add another 4. How do I add another 4? The question is how can I add a 4? That is the question. So I would be like, okay, how can I add a 4? I don't have enough beads. So I need to add, how do I add a 4? I can use the 5. So to plus 4 is equal to plus 5 minus 1. So I plus the 5 minus 1. Okay, great. So my answer is 8. So let's do another 4. So my question is 8 plus 4. 8 plus 4. Do I have enough beads to plus the 4? No, I don't have enough beads to plus the 4. What's another way? Well, the other way is plus the 5, but I'm already using it, so I can't do that. So what's another way? Now we're going to do making a 10. Now the concept of making a 10 will come into effect. Why? Because that's just the way it is. But we're teaching this in school, right? We're teaching the kids that 4 plus 6 is equal to 10. Or we say 6 plus 4 is equal to 10. Excuse my handwriting. And then we go back, and because I'm talking to adults, what we're going to do is we're going to isolate the variable. What does that mean? We're going to take this 4. We're going to take this 4, and we're going to move this to the other side. We're going to jump the fence. So what does that mean? We're going to eliminate the 6, right? And we're going to add it to this side. So what we're doing is we're isolating this variable. When we isolate this variable, I'm going to rewrite it. We say plus 4 is equal to plus the 10 minus 6. When I plus the 4, when I plus this 4, I want to plus the 10 minus the 6. Now this is where we start coming into introducing things like 10 is the next set of 5. Yes, exactly. And then what I was thinking about is now we actually start introducing the concept of grouping, regrouping, carrying on, and borrowing. Those are all the different things, right? Grouping and carrying on is an addition. Regrouping and borrowing is another addition. So you're actually basically 10 pair subtraction. Yes. So in America, we call it making a 10. And so what we're doing is we will always know that the 4 and the 6 is a pair, no matter what, right? Or the other one is 4 and a 5. These will always be a pair, no matter what. And this is the fundamental idea. So when we do it, right, we have 4 and 6 is the 10 pair, right? So these two concepts is what will be the basis for everything. What can you show me regrouping? My second grader came home with that. What makes them a pair? What makes these two a pair is what you're trying to do with it. So what we're trying to do is we're trying to make a 5. That's why it's a pair. We're going to try to make a 10. This is why. That's the only thing. That's the only thing. If you bring it down to like the fundamentals, the only thing we're trying to do is make a 5 and make a 10. If you can make a 5, you can do everything. If you can make a 10, you can do everything, right? So your second grader, if you want to start them on the abacus, we have to start from the beginning and get them to understand how to read the abacus. When they learn how to read the abacus, then they start making a 5. After they make the 5, which is, after they make the 5, then they can make a 10, and then they can make a 10. Can you do it the other way? Yeah, you could do it the other way. It'd just be different questions. Yeah, you could do it the other way. We could start off with making a 10. You don't need to know how to make a 5. But it's just nice. Maybe it's easier to make a 10 first. It's up to you. You know what? That's a good idea. So, okay, so I'm back to here. I'm sorry. Let me finish this. So here, we're making a 10. When we make a 10, we're going to move the 6 over. So what we're going to do is we're going to carry over, right? In the terminologies, we talk about carrying over, but in abacus we say plus 10. The reason why we say plus 10 is the only thing that we're doing is we're going to go to the next column. So if I'm here at the 4 and I want to add the 4, I only go to the next column over to add a 10. That's all I'm doing. So you could be here, you could be at the hundreds column, and if I need to, so I'm going to do the hundreds column, right? This is 800, and I want to add 400. What do? I add the 10. So that just means I'm going to go to the next column. That's it. That's all it is. So I'm going to go to the next column, and I'm going to add the 10. That's what adding the 10 is. And then I take away the 6. I take away the 6. In abacus, we don't say take away the 400, because already on the abacus, it's doing that for me, right? So what we're trying to do is we're trying to move the beads, and then when we're done with the moving the beads, then we come back and we be like, okay, what is my answer? And then we start to write it out. So that's the difference. That's the difference, if that makes sense. Let me know if you have any questions. But I mean, this right now, what we're doing is still the fundamental of understanding everything. You could, LT, you could start with getting your child to understand how to make a 10. When they start understanding how to make a 10, then you can carry on to figure out how to carry over. But because we're doing it this way, these are the fundamental formulas that they have to understand. So let me rewrite the fundamental formulas, right, to make a 10. To make a 10, we can start 9 plus 1 is equal to 10, right? And then let's do 8 plus 2 is 10. Right? And we just go down. And this is how you make a 10. This is the fundamental thing. 6 plus 4, and then 5 plus 5. When we do it in abacus, this is why we need to know how to make a 10. When we do it in abacus, we know that we could do plus 9 is equal to plus the 10 minus 1. We can do not the inverse, because the inverse is minus 9 is equal to minus 10 plus 1. So the inverse is that. It's not the reverse. So the next one, what I'm trying to figure out is, what would be the number is when we do minus the 1 is equal to minus the 10, or plus the 1 is equal to plus the 10 minus 9. See how it's kind of relatable? They kind of relate to each other. So if I add a 9, I have to take away the 1. If I add the 1, I have to take away the 9, if I need to, right? So then it goes back to this, right? 8 plus the 8 is equal to plus 10 minus 2, or the other way, right? Plus 2 is equal to plus the 10 minus 8. Anybody have any questions? So I'm going to continue on with so this is what we call making a 10. We understand the concept of making a 10 in school, but then we take it in abacus, we take it one step further. They are sentences sisters. Oh, that's brilliant. Sentences sisters. Can they be sentences brothers? Is there a difference? If they're you know what I mean? Like then we go into the gender and all this and that, and I'm like, I don't want to. I'm just going down the political route of being woke and stuff, and I'm going to stop it from there. But that's really cool. Sentences. There you go. Sentence siblings. Yes, like a snowman is not a snowman; it's a snow person. I'm going to make a snow person, and I'll be a little bit more woke. I'm not here to offend. I'm just here to be funny. We're just talking about being funny. You do you. I'm just here about, I'm confused. It's called the abacus or a soroban. Soroban is the Japanese version. That's all it is. Abacus is the thing to move, right? So we have the soroban. Soroban. This is the Japanese abacus. This is the Chinese abacus. Still an abacus because we have beads. This is called supan. That's it. It's the same. But it depends on what you're trying to do. You learn the Chinese abacus, it's supan. If you want to learn the abacus, the Japanese abacus, it's the soroban. There's another one called the Russian abacus. There's another one that's that's Dutch. It's called a Reckenreck. And then there's another one called the Kramer. So but they're all the abacus. They're all abacus. But when we talk about if you want to be more specific, you would call it a soroban. That's the only thing. So, yeah, thank you, Blue Bubbles, for all of the different name, same mechanism. Yeah, different name, same mechanism. Different name, same mechanism. Yeah, I guess so. Yeah, that would make sense. Because you still move the beads. The idea is moving the beads. That's why it's called an abacus, because you're actually moving beads. I think they were talking about like a Greek term, beads. I don't know. I have to research a little bit more about it. But it's something like abacus. The word abacus just means moving beads. But yeah, sibling sisters. I will have to start remembering these things. Sibling sisters and number sentences. Yeah, and that was the one thing. This was the path I was trying to go down. Like trying to connect the math terminologies being used in mainstream math to how it's being used in abacus. And that was the one thing, like if you researched on YouTube, they don't talk about, like the people that are teaching you math on the abacus way, we have our own set of, I'm glad I can help from mainstream school. Yeah, Thank you. Yeah. So like making a 10, like I was starting to figure out like, oh, we do make a 10, but we don't call it that. We call it, some people call it big friends, some people call it family, some people call it plus tens, right? We have our own set of vernacular, we have our own set of vocabulary in abacus world. So what I'm trying to do is I'm trying to marriage the two and show that it's actually quite the same. It's just we use different words. So like making a 10, doing the 10 pair, doing a 5 pair, like we don't, in abacus, we don't call it that. We just say, you know what, memorize the formulas. But, you know, formula is a formula. So with these formulas, it very much lends itself to algebra. So, yeah. Okay. I have a hard 15 minutes. So I have 15 more minutes for this live because I have to go take a friend to the doctor's. However, does anybody have any questions? If not, I will continue on just my train of thought. Which was what? What age to start? You know what? Before I started going down this path, we usually started kids at 5 because we wanted the kids to learn their numbers. But I actually wanted them to go further. So I start children at 3. And so I have, the reason why was because I wanted them to start learning how to count on the abacus. So I wanted to provide worksheets to start the kids when they're 3, 4, and 5. So I started my students, I have students that came in and they were like right around 3 or 4. My one student that started at 3, he's been doing like just learning how to read the abacus and learning how to, and how to count. So now he's 4 and now we're actually going to go into adding and subtracting. I have a 5-year-old, that's perfect. If you have a 5-year-old, you could start going into, you could just, I would start doing that right now, right away. When you start going into understanding how to teach, I would just count it 1, 2, 3, and then I have the activities. So if you're okay, I do have one. Depending on how fast or slow you want to teach your child to go straight into adding and subtracting, I have other books, but they're a little bit more themed. I didn't think that anybody would be interested, so I didn't go further in. I am planning to make an introduction to abacus without the theme, but because your child is 6 and since your child is 5 and you only want them to learn how to read the abacus, I have the Halloween one, and it only goes from 0 to 10, and this is straight like just talking about how to read the abacus and how and do bead recognition. So here I have a maze. Oh yeah, this is a maze and it's kind of cool. I kind of like it. So you start from here. It says 7. Start from here and we have the number 7 and you trace the number 7, and then the idea is, do I go to the right or do I go down for the next number? I'm looking for the number 7, so this does not look like 7. So what I want is I wanted the children to see, okay, I go here. Now the next thing is you see that there's a blank box. Well, what does that mean? The idea is, behind it, is to grab your dough balls. I can't say Play-Doh in the book because it is trademark. So if you take your dough balls and you place 7 dough balls in this corner, in this box. Now one thing was trying to get them to engineer, like how are you going to put 7 dough balls into this little square. So that was the idea. And then also to get them to start using their fingers, right? So I try to make it interactive. And then again, to recognize that this is the number 7 and this is the 7. And so the idea here was that there's a path and this is a maze. So this is my number maze that I created. And that's what I have in this book. And, you know, we do some tracing and some, I try to add in the 10 frame just to relate to what school is doing. And then there's cutting. And then there's more cutting. So this is the clip. This is clothespin. I'm not sure if you know about the clothespin activity. The idea here was they would have to write it out. And then, so if they write it out, it looks like this. So it's about tracing, right? And then here is the number 2. What I have it is you would cut and then you would, you know, figure out where the 2 is. So here I have the 2 over here. And then I have like other prompts here where it'd be like, okay, these are the cards. So sort these cards. Oh, the idea was to clip the 2 and make sure they're together so you can kind of match it. And then that was the thing, is like you could play memory with it, right? Well, if your cards are a little thin, you would have to put like something behind it so it's a little bit not as see-through. But I had some prompts that you can clip the card. You know, you can clip the card with the same number. So I have a 2 and a 2. You can have the number for 4. So what number is before 2 is 1. So you clip it like that. Or what is the number after 2, right? So these are some of the activities. These are some of the prompts that I have in here. You can also play memory with the 2 cards. And then because you have multiple cards, right? You have multiple cards. You only go up to 10. So you have the multiple cards. You can sort them. You can sort them in ascending order, descending order, evens or odds. And then you could do the what number comes before and what number comes after. Now, if your child is okay with like understanding like the bead recognition stuff, you could start off with the Christmas one. The Christmas one goes, he is on the EYFS curriculum, so he's about age 3 and 4. I don't know all the acronyms. What is EYFS? Okay, I'm going to continue on with this. So the Christmas one is, again, we still talk about bead recognition, right? We still talk about, you know, here's the quantity and find the quantity and so forth. And then there's a number recognition, early years foundation stage, nursery. Oh wow, wow, that's a mouthful. Okay, oh, interesting. So if you want to, I think this would be sufficient. But if you want to push them along, I don't believe in pushing, right? But if you want them to be like up to speed, you could do the Christmas one. The Christmas one doesn't talk about counting before and counting after. This one, the preschool one, I talk about counting before and what comes after, what comes in between. So it's a little bit more. It's a little bit more about the relationship of the numbers. So there's a few more chapters in between, like counting backwards, counting forward, and then I talk about like what numbers are greater and what numbers are less than. So this is a little bit more about. This is a little bit more about the number relationship, and then it goes, and towards the end it goes into adding and subtracting, which still does it in the Christmas one, but now we're doing up to 20. The numbers are still simple. It's still trying to figure out how to do things, right? So if I add the 5, this is how I add the 5. And it's the same thing if it's a double digit. I would, maybe this would be too much. No, he could do 5. He could do it. So then this one's a little puzzle. This one was like, what number comes before that's on the board? So here is 10, right? Because it's a 1 and a 0. So then I have to find out where the 9 is. And that would be 9 is right here. So, yeah, I think so. I mean, if he's in the early years foundation stage, I mean, for my one student who started at 3, he's still working through this. And I've had him for more than a year now. And right now I'm actually starting to do adding and subtracting. Today will be the first day that we will add and subtract. I stayed really close to making sure that he understood how to read the abacus, because sometimes, because my student is also online, and it sounds like that you're a very involved parent, so you're going to go through the curriculum. I do lessons. I have an online with pre-recorded lessons. I do Zoom lessons, but that's a different price point. If you want, we can talk about it offline, and I can tell you like what I have. But I do have pre-recorded, and that one is like, I have all of the videos for all of the worksheets, and you can download all the worksheets, or you can buy the book from Amazon. It's up to you. And there are pre-recorded videos, and I just go through each of the worksheet, like what I was expecting and stuff. So here, I get them to figure out, what color they want, what number is here, right? And then they have to find a path. It doesn't matter what the path is. They just find a path to get to the number. So this is the number 9. So I wanted them to figure out a path to get to this number 9. So I saw a Japanese abacus kindergarten here in TikTok. He's actually counting really big numbers fast mentally. Yes. You know what? Honestly, my children will calculate way faster than me because it's ingrained. They learned it when they were young. So what happens is like, because they learn it, it has now come muscle memory. So when they start doing things, it's like super fast. Can they do it in their heads? They could if you push them. but I didn't push them. I just wanted to make sure that they had a strong sense of numbers. Those kids that can do it in their head like super fast, that's what they do. Is like they do it hours at a time. I didn't want to spend hours. Being a young parent at the time and making sure that they go outside and do activities and stuff, I wanted to make sure. Oh, thank you for the chili. What I wanted to make sure is I wanted them to be well rounded. So my kids are in, like, at the time, right? They're in baseball, soccer, swimming. Right now they're in track and cross country. So for me, I wanted to be more balanced, right? I didn't want them to be like super like I want you to go into abacus competition. I was like, no, I want you to understand how to do the abacus. I want you to understand how to do multiplication, division, and then we're okay. When you get to do that and you understand your mistakes, then we can stop the thing. So, is there any more questions? I have 7 more minutes. I just wanted to make sure. The most important thing, I want him to have friends. Yeah, exactly. Exactly. Like, we had a bunch of preschools around the neighborhood, and they were like, this is what we do in academics. I'm like, I'm okay with that. I'm okay with, what I want them to do is I want them to understand how to socially communicate and just, play with friends. So mine wasn't really about academics. I went through the abacus because I feel like that if they went through abacus, then I can worry about their English and their reading later on. I didn't want to have to do two things at once. But when they go through it, I feel like that the activities will help alleviate. I think the activities will help them understand abacus a little bit better. My kids, I'm sad. My kids don't get a chance to do any of this stuff because, as a young parent, there was not enough time to be creative. The most important thing, he's autistic, so I think he's going to struggle socially. Yeah, yeah. I mean, it is what it is, right? Um, it is what it is. But when he gets older, I think he'll be fine. I think when we get older, we have more it, yeah, I think when we get older, we have more patience and we're more open to things. And we'll find people, right? I mean, the internet is now huge, right? The internet opens up a lot of things. Whether we're on TikTok, Facebook, or whatever, we're going to find our people. So I think he will be fine because he will find his people, which is crazy. When I was a kid, our people was just nobody, right? I was a loner. I didn't have any friends or anything. Because I was different. And because I was like, so I grew up in a very rural Canadian, and there was a lot of Caucasians, and there was a lot of black people, and there was not very many Asians, anything Asian. So I'm also autistic. I have made friends later in life. I don't want him to be lonely. Have to be lonely in childhood. You know, but it might make him a better person. I don't want to spin it as this is a horrible thing. Or you could find friends that will be able to communicate with him. You know what? Let me try to rephrase that because my kid is a loner. They're not on the spectrum, but when my kids started in the beginning, and then we had COVID, and my husband's like, oh my God, I don't know if he has any friends, but as they go through with computers and stuff, it's crazy on how it connects everybody, just like how we're connecting, right? So it's interesting to see that. I think he'll be fine, and maybe find like a Minecraft group if he likes Minecraft. Like my kid, they started Minecraft. I mean, they play Valorant now and Fortnite and stuff and all this and that, and they communicate on the internet. So they have that. I don't know if that's a good thing or a bad thing. It is what it is. And so I'm okay. I think it's parents' worries. And it is true, right? A lot of parents don't want their kids to fall. A lot of parents. My brother and I are very different. My brother's kids are my kids are roughly the same, but they didn't grow up together because the way he parents is not the way I parent. And I'm like, I'm not open. I give boundaries to my child, but they know where to go, right? So what am I trying to say is he would be like the one barking, like, I will tell you to jump when I tell you to jump. And he was very much like, hey, how did you get this wrong? And there was a very much like old thinking. Whereas I'm all about like, really it is what it is, but we learn from our mistakes. And so if he runs and falls, well, he runs and falls. So it does depend, but because we have the internet, your child, I mean, I don't know how you are with the internet, but you can find small groups and pockets of children that will be able to. I'm a gentle parent. Hopefully you're not too gentle. Don't be passive aggressive. I yell. I don't hit. But I do have expectations, like, pick up after yourself, make sure things are okay. But there's expectations also, right? Like, do your work. That's what you have to do. There's certain things that they have to do. So, good luck. I hope. I'm not. You know what? I'm so sorry. I'm so sorry. I'm not here to give you advice. I'm here to talk about abacus. I'm not qualified to. I'm not qualified. Yeah. Oh, I shall. Oh, yeah. Yeah. Oh, yeah. I'm not here to qualify that I'm teaching. I'm just, this is what I was doing in my thing. So I'm a parent. Yes. I have 3 boys and they're always asking me, who's the favorite child? And I go, the one that listens and the one that's not crying. That's my favorite child. If I'm a parent, I do gentle parent if they only behave. Yeah. So, but again, I don't want it to be like, I'm not here to push anything. I'm just here to teach abacus. And if you have any questions about abacus, let me know. I am here. I'm always live. Apparently, I'm always on live. But I will be on live often because I feel like that, people need to know that abacus is the greatest thing next to sliced bread. And it's easy to use. Depending on what live you get, we can go into going into multiplication division. You can do that. You can do multiplication division with the decimals as well. Hi, Alma. Welcome back. It is 10:30 for me, and I was actually going to do a hard stop at 10:30 because I'm going to take my friend to the doctor's office because she has an appointment, and then after that I have a class, and then after the class I'll come back on. Because I get excited to teach and to do like abacus and stuff. Yes, bye for now, and I will see you. Then again, okay, one more thing, last thing. Anybody have any questions? I just, write them up and we will answer them in the next live. Yeah? Sounds good? So I will catch you guys in the next live. It's a nice day. It's 6 p.m. Oh, where are you located? I'm now curious. I'm assuming that you're somewhere in Europe. Yeah, I have a couple of people from like Finland. Oh, okay, UK. I have a couple of people that's like in Norway and Finland and Poland and Uganda. And then I have somebody in Liberia and so forth. So I'm a little international. Yeah, and he's in the Philippines. You should go to sleep, Ethan. Go to sleep. Go to sleep. All right. Thank you, everybody, for joining me. I will go on live. Catch me on the next live. I will see you guys next time. If you have any questions, write them up and we will work on them. Bye. It was nice talking with you. Thank you so much, Blue Bubbles, for your insight on the terminologies. Thank you so much. Bye. Go to bed, Ethan. Bye, Alma. All right. End live.